Hello everybody, this is the first video for Cumulative Review Packet number 13. Let's start here with number 1. Find the limit using the graph on the right. So first, we're trying to find the limit as you are approaching -1 from the left side, and I know it's the left because there's a little negative there. So we're looking at the x value of 1, which is right here, and we're coming from the left. So the graph is going up and then going down, and we're approaching and approaching and approaching x equals 1. And the y value we're approaching but not touching is +1. If we were to find the answer to part B, as x is approaching 1 from the right, my graph all the way to the right is like this. Then we go to the other side of the vertical asymptote. We are coming down, and then we are approaching +1, x equals +1. But this time, we are approaching -1 as a y value, not +1. Which means that the answer to the limit as x is approaching 1 is the limit the same from the left and the right? No, it's not. So my limit at 1 exactly does not exist. My limit as x is approaching 4 from the right. So let me erase this here. So this time we're looking at the x value of 4. So as we're approaching from 4 to the right side, it looks like my graph is starting here and then going up to +infinity. So 4 from the right is +infinity. 4 from the left side of the graph also is +infinity. So you could say that the limit at 4 exactly would also be +infinity because it's the same from the left and the right. However, all of these you also could say the answer is does not exist, and here's why. Remember that a limit really means what y value you're getting close to. So as you're approaching from the left, you're going up to +infinity, but +infinity isn't technically a y value you can touch. So you could say that the limit also doesn't exist. You could say the same from the left, and you could say the same when you're comparing both sides. But I completely understand, and I'm fine with if you have the answers as infinity. Sorry about that. My computer is freaking out. So your answer is infinity for every single one, but I also would accept any. So the next example here, the limit as x is going to -2. Now this time we do not have a direction, so you're looking at x equals -2, and you're looking from both sides at the same time. So if you're looking from the left, we are approaching the y value of 3. If we're looking from the right, we are also approaching the y value of 3. So the limit exists at that y value of 3. If we look at the limit as x is approaching +3, so we are looking right here. As we come from the left, the x value that we're approaching right here is 0. If we're coming from the right, we are also approaching 0. So the limit exists at 0. The next example, find the limit as x is going to infinity. So that means that we're looking forever to the right. And some of you might recognize this graph was on a previous exit slip, or something very similar at least. So as we're going to the right forever, what is my graph doing? Well, it looks like the graph is starting to level out at the horizontal asymptote y equals 0. So this graph is going to get closer and closer and closer and closer to this horizontal asymptote, but not touch it. And where is this horizontal asymptote? At y equals 0. So your limit is going to be 0 because as your graph is going farther to the right, you're approaching 0 but not touching it. The answer for f of 1, now these mean what are the exact y value. If you go over to +1, we have 2 possible dots, but this one's a hole. So the actual y value that exists is -1. If we look at f of 4, that means we're looking at the x value of 4. Notice there's a vertical asymptote at the x value of 4. So that means that there's no y values that go with that x value. So this does not exist at all. Numbers 2 and 3 are asking you to find the domain, zeros, holes, and vertical asymptotes. This is a smaller version of graphing the rational functions that we just did. So if we take a look at number 2, again, these are written in a particular order on purpose. My suggestion would be always to find the domain first, and both of these are found without crossing anything out. You're going to factor, but not cross anything out. So for number 2, my numerator factors to be x plus 1, x minus 1. My denominator, I can take a GCF out of x, and I'm left with x squared plus 8x plus 7. So I have x plus 1, x minus 1, x times x plus 7, and x plus 1. So before, again, I cross anything out, my domain has to do with my denominator. I can see that x cannot be 3 values. It cannot be 0, cannot be negative 7, and it cannot be negative 1, which means my domain is everything else. Negative infinity to negative 7, union negative 7 to negative 1, union negative 1 to negative 1 to 0, and then from 0 to infinity. My wholes are found by what's crossed out. So I have an x plus 1 on top and bottom. So my whole is going to be at negative 1 comma something. Again, the reason it's negative 1 is because you set this equal to 0 in your head. We are going to find the y value of this whole. We are going to plug the x value into the reduced version of my polynomial, which is x minus 1 over x times x plus 7. So if I take negative 1 and plug it in here, I will get negative 2 on the top, and I would get negative 1 times 6 on the bottom. Because you do negative 1 plus 7 times negative 1. So this is really negative 2 over negative 6, which is positive 1/3. My zeros are what's left over in the reduced version. And again, the reduced version of this polynomial is this piece right here. The zeros is what's left in the numerator, and the vertical asymptotes is what's left in your denominator. So my zeros, my factor in the top is x minus 1, which means my 0 is positive 1 comma 0. My vertical asymptotes, this time there are 2 because we have 2 factors left in the denominator. X equals 0 is a line you can't cross, and x equals negative 7 is a line you can't cross. Number 3 is the same idea. So what we're going to do first is factor this. We'd have x plus 4 over x plus 4, x minus 3. So my domain, I know that x cannot be negative 4 and x cannot be positive 3. So my domain would be negative infinity to negative 4, union negative 4 to 3, union 3 to infinity. My wholes, if there's anything that crosses out, I have a whole that exists. So if I look at this example, we can cross out the x plus 4s, which means that my whole is at, I'm sorry, but my screen keeps jumping, super annoying. So my whole is at negative 4 comma something. The reduced version of this polynomial would be 1 over x minus 3, the 1 as a placeholder because you crossed out what was in the numerator. I'm going to take negative 4 and plug it into the reduced version, so that would be negative 1/7. So my point is negative 4, negative 1/7. Now this time, if we think about zeros, the reduced version is 1 over x minus 3. So this time, there is nothing left in the numerator other than a 1. There's nothing we can set equal to 0. So that means this example, there are no zeros, there's none at all. Vertical asymptotes, though, there is something left in the denominator, x minus 3. So my vertical asymptote would be x equals positive 3. Find each limit algebraically. And so when you're doing these problems, my suggestion first would be to plug in the x value that you're approaching to see if you get a y value straight away. So for the first example, if I take 3 and I plug it in everywhere I see an x, let's see if we get a y value out. So that would be 4 times, make sure you do the order of operations and square first, minus 27 plus 2, 36 minus 27 plus 2, so that would be 9 plus 2, so that's 11. So that means our y value that we're approaching, but not necessarily touching, is positive 11. So that one wasn't bad, because when we plug things in, we got something right away. Remember, a limit means as you're approaching a particular x value, what y value are you also approaching? Number 5, if I am trying to find the limit as x is approaching 4. First thing I'm going to do is plug in 4 top and bottom. However, this time I get 16 minus 16 on the top, 4 minus 4 on the bottom, so I get 0 over 0, which is the indeterminate form. I can't divide by 0, so that means I need to, according to Mr. McConey, I like it very much, keep going. So what you need to do is change how this function looks so you can find the limit a different way. We're finding the limit as x is approaching 4. Now I notice that we can manipulate this function by factoring it. The top becomes x plus 4, x minus 4, and the bottom is 4 minus x. Now it's really tempting to cross out these two right now, but they're not actually the same because this x is positive, this x is negative, this 4 is negative, this 4 is positive. However, if I looked at the denominator and thought about taking out a greatest common factor of -1, so if I was finding the limit as x is approaching 4, the numerator stays the same, but if I took out a GCF of -1, the 4 would become negative, and the x would become positive, so this also becomes x minus 4. Now you can cross out the x minus 4s, which is similar to if you were finding the whole of a function. So you'd be finding the limit as x is approaching 4 of this function, x plus 4 over -1. So now if you plug 4 into this function here, you get 4 plus 4 on the top divided by -1 on the bottom. So the y value you're approaching is -8. Number 6, let's try. If we're approaching 0, we're going to plug 0 in first to see if we can get an answer directly. It does not look promising to me because on the top I'm going to get 0 and the bottom I'm going to get 0, so no, that's indeterminate form. So what we need to do is again manipulate what we have. So we have the limit as x is approaching 0. Let's see if factoring will help again, or help. The top, I can take out a GCF of x, and I'm left with x squared plus 5x minus 6. At the bottom, I am left with just x. So what you could do is continue factoring the top. So you'd have x, and then x plus 6, x minus 1, to get the -6 and +5, all over x. This time, the x's cross out, and so you're trying to find the limit as x is approaching 0 of this new function. So you could take 0 and plug it into x plus 6, x minus 1. So it would be 6 times -1. So your answer should be -6. Last one of this type, we're trying to find the limit in a radical function this time. So if I take 9 first and plug it in, we'd get the square root of 9 minus 3 over 9 minus 9. So that would be 3 minus 3 on the top and 9 minus 9 on the bottom, which would be 0 over 0. So again, we have that indeterminate form, which is not helpful. Instead, we need to manipulate this function. Now, this time, we can't factor it because we don't have anything that's squared. What we can do is use conjugate logic. And wherever the root is where you're going to use the conjugate. And even though it's in the numerator this time, that's where the radical is. So you're going to multiply top and bottom by root x plus 3. My suggestion would be to always multiply out the top, but not necessarily the bottom. So if you were doing this first piece, you would FOIL this. You'd have root x times root x, so you'd have the limit as x is approaching 9. Sorry, my pen is starting to freak out here. Root x times root x is x. Root x times 3 is plus 3 root x. Negative 3 times negative root x is minus 3 root x. And then negative 3 times positive 3 is -9. So that's my new numerator after the conjugate. The bottom, I would highly, highly suggest not multiplying out, leaving it as x minus 9 and root x plus 3, because, if I extend the page here, if you notice, the middle terms cross out here. So you are finding the limit as x is approaching 9. In the numerator, you only have x minus 9. And in the denominator, how convenient, you also have an x minus 9. So that means that you can cross these out, and your new function is 1 over root x plus 3. The 1 is there because we crossed out x minus 9. We need a placeholder. So now you're going to take 9 and plug it into the new reduced version. 1 over root 9 plus 3, which would be 1 over 3 plus 3, or 1/6. So the y value that you're approaching would be 1/6. All right, guys, that's going to be the end of this first video. I will start with limits from infinity, the next problems, on video 2.